Jai Hind everyone. Myself, Dr. Ajay Pratap Singh, and I am working as an associate professor in Department of Mechanical Engineering at Ajay Kumar Garden College. And today I teach the tidal power and the kind of the renewable energy resources. And these are useful for the BTech final year uh, students for the renewable energy and resources subject. The code is the KOE 074. So today we'll discuss the tidal energy. How the tidal energy is developed, how to energy conversion of the tidal energy from one phase to the another phase and generation of the electricity. So basic will use the tidal power, and after that we can generation. Then we can discuss the today in class for the introduction of the tidal power. Then single basin system, how the tidal power system. I use the different type of the tidal power system, like single basin system is there, double basin system is there. Then what is the any system, what is the merit and demerit of the system, and that is the tidal energy for environmental effect, what different type of the effect is going on. So in today's lectures I'll discuss the 5 points, and after that conclude this session. So, what is the tidal energy? So, we can say the tidal power exploit the movement of water caused by the tidal content, or we can say that is the rise or fall in the sea by the level due to the tides. So, the power generated through the tide, basically the wavelength, you can say, during this ocean. So, although not at a widely used, it has the potential for the future, you can say, for the electricity generation, and it is more predictable than wind energy or and the solar energy. So we can say these type of the technology required to, we can say, the harness of the tidal energy is well established. However, we can say it remains expensive, and there are relatively few some application around 40 worldwide, around the 40 worldwide. So ocean tide, you can say, are the produce the gravitational by the, you can say, by the gravitational forces of the sun and the moon. So the tide generation with the respect of the movement of, you can say, the gravitational force with the respect of the sun and moon. So there are only few sites in the world where the tidal energy are suitable, can be suitable for the hardness. So we can say the Bay of Funde, the Canada having the 17 to 18 meter height to tides, has, you can say, to generate the potential of the 500 megawatt of power to the generation. In India, the Gulf of the Gulf of Bombay, the Gulf of Kutch, you can say, the Sundarban Delta one, you can say, to generate the power of the site. So these are some generations of the tidal energy. So the tidal power generation is also known as the tidal energy, and it is the kind of renewable energy resources that relies on the tides to generate the electricity. So may as you may or not may known, the tides are created by the gravitational pull of the moon and to a lesser extent to the sun. So changes in the water level which affect, you can say, which affect the tidal currents and the result of the gravitational attraction. So the power of tide in a specific, we can say, the location is caused by the changing of position of the moon and the sun. So the effect, we can say, of the earth of these rotations, and we can find out that the shape of the sea floor and the coastal line. So these are the power of the tide depends on the sea effect of the earth of the rotation. According to that, the position of the moon and the sun will changes, and these effect will see in the sea floor. So and the coastal line. So we can, according to that, the tide power will be generated. So the tidal energy, you can say, can be classified into three different methods. So first one is the tidal steam generator, second is the tidal barrage, and third one the dynamic tidal power. And this way is much less efficient than the other method through the which EV tidal power generation. So we'll discuss here. Tidal steam generator, you can say that tidal steam generator to make use of the kinetic energy of moving water to power turbines, and in a similar way the wind turbines that use for moving of the air. So this method we can say is gaining in popularity because you can say the lower cost and the lower ecological impact compared to the tidal barrage. So tidal barrage, you can say that is the tidal barrage make use of the potential energy in the differences in higher, or we can say the head. So between the high and low tides, and the barrage you can say are essentially dams across the full width of the tidal from the very high civil infrastructure cost. The basically you can say if you making the barrage, so the civil infrastructure cost is the high, and the worldwide we can say the shortage of the available site and the environmental issue are there. So if you are making a building in the seaside area and to make a barrage, so there are different infrastructure qualities required. Then some we affect the environmental conditions. So there are some issues there. So tidal barrage is preferably not used for this tidal energy. Regularly used, you can say. And dynamic tidal power, you can say the exploit and interaction between the potential and the kinetic energy in the tidal flow. It proposed that, for example, you can say the 30 to 50 kilometer length, and dams we build from the coastal straight out into the sea or ocean without enclosing an area. So the tidal phase difference and the tidal phase differences are introduced by the presence of, we can say, the presence and the dimension of the dam, and which is not negligible in the size, or we can say size compared to the local tidal wavelength. So these leads to the hydraulic head difference across the dam, and turbine in the dam you can say are used to convert the power to 6 to 15 gigawatt per dam. So it's shallow the coastal seas featuring, and strong you can say the coastal parallel oscillating of the tidal currents and such as found in the UK. So these are some the tidal in a dynamic tidal of energy, dynamic type of the tidal power energy, and you can say this is the different types of the system based. So we are using the single basing system for the tidal energy, or we can second is the there are two base system, you can say, that is single basing system, and second is the double basing system. So I'll discuss here for the single basing system. So single basing system, you can say this is the simplest system to generate the tidal power, and this scheme has only one basin which is separated from the sea by a dam. So the basin size, the only one basin are used. So in that case, that is the single basin, and when we are using the two basin, so we can say that a double basin. So the sliceway is open during the high tide to full the basin, and used to the empty the basin under the low tide. So we can see there side the basin is there, and the when the full opening of the sluice gate, and when the high tide there, the all the basin is filled with the water, and after that when the water low tide is there, then this rotates empty from the other side. So the water during the high tides is first trapped in the basin and then allowed to escape during the period of the low tides. And the water while escaping, we can say the run of a hydraulic or hydraulic during the coupled to during this then when the movement of this basin is there from during the low tide and high tide, these rotations will convert it with the generator, and this rotation, this energy will convert to the basically the alternator will rotate, and then the electricity will be generated. So in such system, the powerhouse is situated at the mouth of the basin, and the hydraulic turbine into the powerhouse will operate during this discharge of the water from during the EB tide. So we can say that is during this these are the system for the single basin system, and you can see here that is from the figure. This is the barrage, right? This is a sluice gate, and this is the open water system, and this is the basin, you can say, and this is the turbine. So the single basin on one way system to tidal power system, and we also have, you can, the double cycle system in which the power generation is affected during this EB or as well as flood tide, and the direction of the flow through the turbine during the ebb or the flood tides, the alternate and generation of the power is accomplished both during the filling and during the emptying of the basin. So these are the opening of we can say that is the single basin system of the working. So come to the double basin system. So double basin system, we can say this system has two basin. We can say that is the one is the upper basin system and second is the lower basin system in different level, and the dam is provided between the these basin is shown in figure. You can see here that is the inlet sluice gate, right? And these are the upper basin area, that is the lower basin area, right? And the outlet of this sluice gate, and these are the oceans. So water come from here from low tide to high tide, and this movement this go to the sluice gate is the open and enter in the first basin, and come to this rotation of this lower basin is there, and then it outside of the water from when the low tide is there, that water comes from the outer sluice gate. And during the rotations of this during this the energy is converted. So using this hydraulic energy, we can say the hydraulic energy to go to the mechanical energy, and mechanical energy convert to the electrical energy. So the one basin is filled with the high tide, and the other is the empty or the low tide. And turbine, you can say, placed between this between this basin. So these are the turbine placed between both basins, right? So these are working continuously, and we can say the two basins schemes offer the advantage over the normal schemes is that the generation of the time can be adjusted the high flexibility, and it's also possible to generate almost the continuously working. So these double basin system is the continuous supply of the electricity, and we can say that the best system for this. So double basin system, other we can say that when the water level in upper basin is maximum during the high tide, the inlet sluice is closed, right? And the level of the water in the lower basin keeps on rising due to the discharge of the water by the turbine. So when the level of, we can say, the water in lower basin or equal during this the EB tide, so the outlet sluice is open, and it is closed when the water, we can say, the level of reaches to the minimum, it's a minimum level. So the cycle is, we can say, the repeated, which we can say is responsible for the rotation of this turbine. So these are repetitions of the cycle, and the two basin system are very expensive to construct due to the cost of the extra length of the barrage. So we can say initially the initial cost is very high during this development cost, but when the running cost, we can say the running cost is the low, and this system will give the regular we can say the continuation in the moment, we can say, the provide the electricity. So these are best system for the use, but yes, the initial cost is high. So the tidal energy relative merits, we can say there are some merits, and in every system we can say there are some merits and demerits. So we can see here for the tidal energy there are some merit. You can find out the very less area is required because they are on the base. It is free from the pollution, and it does not use any fuel. Basically, you can say the tidal energy we are not using any type of the fuel. So the pollution free, we can say that it is pollution free, because when you use the fuel for any system, then fuel the burn is there. We can burn the fuel, and after that some smoke of carbon monoxide, carbon dioxide is generation. So in that case, we can say that it's the carbon monoxide and carbon dioxide impact on this environment. So in that case, that is, there is no pollutions, right? So it you can say it is a much superior to the hydropower plant, and it is totally depend on of rain, which always fluctuated year to year. It does not produce any unhealthy waste, we can say, like gases, acids, and refuse, etc. So it's a very good thing, because in case of, you can say, the thermal power plant, right? So thermal power plant, like different type of, when we burn the coal, so there are some gases. Uh, we can generate some different type of gases is there. Then fly gas is also. So after that, using this electricity, we can, that is the one of the main uh, uh, drawback, challenges, you can say, that is the in case of the thermal power plant, that is the storage of the fly gases, right? And how to use that. So there are a lot of you can say, that is the lot of fly gases there. So that is one is the transportation cost involved. I want transport the one place to another place. Second thing, the storage problems is there. Fourth thing is there. Third thing, like there are different type of, during this transportation, the pollution is there. So the dust uh, move in this environment. So this harmful for, we can say, the any people or maybe any living thing. So there are some drawback in the thermal power plant. So in that case, there is tidal energy. There are no any type of this unhealthy gases or the fly gases or diffusion generation. So it's very helpful. So tidal power, we can have the unique capacity to meet the peak power demand effectively when it's work in the combination with the thermal and hydropower system. So we can say that is a very useful to fulfill the with the peak power demand effectively during this hydro, and it's used for, basically it's work only when the thermal power plant, and hydropower plant, and the tidal power plant combined to. Some limitations, we can say, the tidal energy. The we can say that is the following are some limitations of the tidal energy that should be looked upon with the utmost care. So we can say the tidal power is not all cost effective, as it is. We can say it seems to be the first place compared to the natural gas and coal plants generating power. So we can say more so the power stations, or we can say in terms, also added up some carbon contents, or we can say in carbon contents in the atmosphere, and as a fossil fuel is needed to run these power stations. So we can say, besides wildlife is displaced from their regular habitat. And second thing, we can say that tidal power can't be generated in inland, and we can say uh, can be used where there is appropriate wave motion of the tidal flow. So we can say that it can only produce the electricity when there is a tidal surge, surge not every time. So there are some limitations of the tidal powers. Another limitation is that the barrage system of the tidal power generation is a lot of the maintenance and salt resistant part. And these barrage, we can say, the disrupted the fish migrations, and at the same time kill some of these them while they try to pass through the turbine frame. So we can say that again the disrupt the fish migrations, because when fish market is India, in case of the India, that is the second largest market of the generation of the fish. So that we fish not passes through the barrage, we can say directly go to the turbine. So it's harmful for any animal, or we can say for anything. So the besides this, the disturb the movement of the ships through the canal channel, or we can, on which the barrage is built. Tidal power is limited. We can say as the tide never slow down or speed up, and at the same time occurs the cycle of the 6 hours. So that is the main thing there. The cycle hours is the 6 hours, and beside the tidal power, we can say is also dependent on the fake distance, and hardly any suitable fake distance is available, and whenever available in the cast region, at to almost 1.2 billion in setting up the you can say setting up of the facility. So these are the some limitations of this tidal energy. And what is the impact of this? We can say for the tidal energy, you can say the changes the hydrology and salinity. Second thing, marine life is affected. We can say the changes of the hydrology and the salinity. Second thing, the marine life is affected. Third is the changes in environmental climate, and it's responsible for the loss of some species. So there are some impact on this environment, and it's very harmful, we can say. Uh, so we can say here in the tidal energy is the only we can say the one of the best solutions to produce the renewable energy, and double basin system is the one of the best system to use. Where we can say the double basin system can use, and you can generate the electricity in the continuous form. And when you can say the tidal energy is the one of the best when with the combination of we can say with thermal energy and the hydraulic energy, and you use this combination that will supply to the to at the time of the peak demand area. Then combination will be required. So there are some I'll discuss here. So thank you so much for this. If you have any query, so just you mail me in my mail ID, the Pratap Ajay @ akgc.ac.in. Thank you so much.